So, the goal for today, hopefully by the end of the period, you'll be able to solve problems involving similar right triangles formed by an altitude drawn to the hypotenuse of a right triangle, and also to use geometric mean to solve problems. Okay, we're still dealing with similar triangles, which means we're still dealing with proportions and things of that nature. You have a few theorems that are listed right there on the front page. You have examples on the back. It says that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So that means, if I have a right triangle, okay, and I would suggest that you draw this as well. If I have a right triangle, and I label it A, B, and C. It says if the altitude is drawn to the hypotenuse, altitude. Does anybody know another word for altitude?
Height.
Height. So there's a height drawn from or to your hypotenuse. That means it would have to come from the right angle. Right. So I'm drawing in an altitude, an extra one. And it, like you said, it has to be perpendicular. So I'm going to draw an altitude. And it's going to be perpendicular to the hypotenuse. That point, I'm going to label it D. Then that theorem says that the two triangles that were formed are similar to the big triangle and to each other. So in other words, certain sides are going to be proportional to each other. Okay? So, if I were to look, we have three triangles here, don't we? We have the big orange triangle, which is A, B, C. We have this triangle right here. Okay? I'm going to draw it right here. What's my right angle? In the blue one? D. Okay? And now the question becomes, BD in the blue triangle matches up to what side in the orange triangle?
BCC.
In the orange triangle? BC represents the hypotenuse of the big triangle. It's going to represent, think about it, if I took this triangle and I were to turn it, it would match up with AC. Okay, so B would go here. And so then A would be at the top. Does everybody see that? Can everyone visually see me? If I take it and I can turn it clockwise, how they match up? Okay. Now take the purple triangle. What's my right angle? It's still D. DC matches up with what side in the orange triangle? Say a little more with confidence, a little louder.
DC.
AC. AC. And then A would match up with what in the big triangle? B. This is how they are related, okay? Now if you wanted to, you could draw this, you could cut it out, and then you could actually physically turn, move them, adjust them how you would need to. But the thing is that you would need to see which parts are proportional to each other to set up your respective proportions. So, okay? Questions? So when you draw an altitude, it makes basically three similar triangles, the two small ones and the big one. The altitude geometric mean theorem states that in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. That's what it does. Okay? Now, the length of the altitude is the geometric mean of the lengths of the two segments. Have anybody ever heard geometric mean before? Casey, hands.
Wait, say what?
Has anyone ever heard of geometric mean? You weren't here on Monday. Hand down. Has anybody ever heard of geometric mean before? Does anybody know what regular mean is?
Yes.
And then what is it?
Add up a certain amount of numbers.
It's,
how many
you
numbers
average the numbers.
It's average. You add up the numbers and you divide, okay? Well, geometric mean is similar, okay? You're dividing here. More specifically, you have two sets in which you're dividing, okay? So, if the altitude is the geometric mean, that means that whatever the hypotenuse is, whether it's an actual length or an actual, or if it's a variable, then that means when you set up your proportion, the length of the altitude is going to go at the bottom on one side and the top on the other. And the lengths of the two sides of the hypotenuse are going to go in the other spots. So that means one part of the hypotenuse will go on top, and the other part will go down at the bottom. That is geometric mean, okay? Whatever the geometric mean is, it goes in the bottom left, top right, and whatever else goes on the other two. Yes?
For us to create a right angle, the altitude can only intersect the hypotenuse of a certain fixed range.
Right?
So wouldn't that make it reverse?
It depends on how long the other two sides are. And so if it was an isosceles triangle, then yeah, it would create two congruent pieces, but all these triangles are not going to be isosceles right triangles.
Okay.
And that's why it says that they're similar to each other. Okay? So, questions on geometric mean? Or questions on how to set this up? Arm. Okay. You want to see an example of this? Okay. Flip over. Alright. Here, in number 1, you see your right triangle. Everyone sees the big right triangle? And everyone sees the altitude that was drawn to the hypotenuse to create the 90-degree angle? Okay. So we could actually set up a proportion here, which is kind of already set up, just one spot's missing, and then solve to find the value of x. So since it's the altitude, you know that the altitude is the geometric mean between the parts of the hypotenuse. So the original setup is altitude here and altitude here, one part of the hypotenuse, and then the other part of the hypotenuse.
So 12.
So 12 is what goes in the blank spot. Because your altitude is 12, right? So it needs to go diagonally from each other. Bottom left, top right, and then the other two parts of the hypotenuse have to go in those missing spots. Does everybody see that?
Oh.
And so then from here, all we do is cross multiply. X times 8 equals 144. Divide both sides by 8, and x equals 18. Alright, let's look at number 2. Does everyone see the bright triangle? Everyone sees the altitude? Okay, so the altitude is the geometric mean between the two parts of the hypotenuse. So I have my x to represent my altitude, that's already there. What goes in that blank spot? 5. How'd you get 5? 20 minus 5, 20 minus 15. And so cross multiply. X times x is,
2x.
as if I'm adding,
X squared.
x squared.
Just kidding.
And what's 15 times 5? So to solve for x, you're going to take the square root of 75, and that will give you a decimal because that's not a perfect square. So let's simplify this.
5 root 3.
It's going to be 5 root 3. What two numbers multiply to give you 75?
25 and 30.
25 and 3. 3 is prime. Break down 25. So I have a pair of 5s and one lone 3. So there's x. Yes, question.
Will there be a time when they use one leg and then you have to do the back and the
Possibly. But there's also could be a time when they give you a leg and then you can use the other theorem to help you find that leg. Now for number 3, could I use this formula?
No.
Why not?
Because X isn't on the, altitude.
Because x is on the altitude. That's for the next part, okay? That's for the next set of theorems. Is there any other example on this page that represents the altitude, which we can find? Like from, so 4 through 9.
Number 8.
Number 6.
Number 8, isn't x the altitude?
Yes.
Okay, so let's set this up. Do number 8. I want you to set it up, and I want you to solve for x. Is there another one on this page where I can find the altitude?
Yes.
Number 6 asks you to find xz. Is xz an altitude?
7.
No? There's one more. It's 4.
Yeah.
Because QS, it says find QS. Isn't QS altitude? Okay, do number 4. So any questions on that? On altitude, how to find it?
This is tough.
This is tough. That's the simplifying part. That was the one we first learned that.
Hey, I hope they give us these